Hey y'all, this is your February district checkpoint test. There are 15 questions. I'm going to read each one and you can follow along. Be sure you're circling your answers on the test and then also bubbling it into the bubble sheet. And if you need to rewind, fast forward, pause, any of that, feel free to do so at any time. All right, number 1 says, the picture shows the motion of a ball dropped from rest from the top of a 2-story building. Use the picture to answer the 2 questions that follow. So we have a boy at the top of the building and we have point 1, point 2, point 3, and point 4. And the question says, when does the ball have 0 kinetic energy? A, points 1 and 2. B, points 1 and 4. C, points 2 and 3, or D, points 3 and 4. All right, number 2, you're going to use the picture again. It says, at which point does the ball have the most potential energy? F, point 1, G, point 2, H, point 3, or J, point 4. All right, number 3. Determine the speed in meters per second of a bowling ball that rolls 12 meters in 2.2 seconds. Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. So if you need to use this area to do your calculation, you can. Go ahead and pause. And then when you're all the way done and you've bubbled it in on your answer sheet, you can go ahead and flip and move on to number 4. All right, number 4. A demonstration helps students understand a principle of roller coaster design. So our picture is titled Motion Demonstration Model, and it says the ball's mass is 2 kilograms. It says the ball is released at this point, which is 4 meters from the ground. And then we have a measurement at 2 meters from the ground. Here's the ball at point W. 1 meter from the ground, here's point X. The ball at point Y, the ball at point Z, and here it's at 3 meters above the ground. Which answer choice correctly describes the ball's kinetic and potential energy? F, the ball has more potential energy at position X than at position Z. G, the potential energy and kinetic energy of the ball are equal at position X. H, the potential energy and kinetic energy of the ball are greatest at position Z. Or J, the ball has more kinetic energy at position Y than at position W. Number 5. The diagram below shows a ball rolling down a hill. Use the diagram and your knowledge of science to answer the question that follows. So you have the ball, a picture of it at point A, B, C, and D. It shows where the ball is at in each box. The ball at rest at the top of hill in box A possesses A, potential energy, but not kinetic energy. B, neither potential nor kinetic energy. C, kinetic energy, but not potential energy. Or D, some potential energy and some kinetic energy. When you're ready, you can turn the page to move to number 6. If you need to rewind or pause, feel free to do that now. Number 6. Students begin to measure the speed of a ball rolling down a ramp. The graph below shows their results. So we have our distance and our time. What is the average speed of the ball? F, 4 meters per second, G, 5 meters per second, H, 14 meters per second, or J, 20 meters per second. If you need to pause to do your calculation, feel free to do that right now. All right, number 7. Changes in motion of an object are determined by A, its density, B, the size and direction of forces acting on it, C, its chemical properties, or D, the renewable resources available. Number 8, a student walks for 2.0 hours and travels 5.0 kilometers. What's the average speed of the student? F, 2.0 kilometers per hour. G, 2.5 kilometers per hour. H, 3.0 kilometers per hour. Or J, 5.0 kilometers per hour. All right, if you're ready, flip the page. If not, pause and rewind and do what you need to do. Number 9. Says the distance a toy car travels over time is shown in the graph. So motion of a toy car. We have the distance and time. And here's our graph. Which table best shows the average speed of the toy car at different time intervals? So A says between 0 and 2 seconds, the ball was going 1 meter per second. Between 2 and 4 seconds, the ball was going 0.5 meters per second. And between 4 and 6 seconds, the ball is going 0 meters per second. B says between 0 and 2 seconds, it's going 2 meters per second. Between 2 and 4 seconds, it's going 0.75 meters per second. In between 4 and 6 seconds, it's going 0.75 meters per second. C says between 0 and 2 seconds, it travels 2.0 meters per second. Between 2 and 4 seconds, the car travels 3.0 meters per second. And between 4 and 6 seconds, the car travels 3.0 meters per second. D, between 0 and 2 seconds, it goes 1.0 meter per second. Between 2 and 4 seconds, the car travels 0.75 meters per second. Between 4 to 6 seconds, the car travels 0 meters per second. You may need to pause and do a calculation for this one, and it may take a little while, but when you're ready, you can click play and move on, or rewind and do what you need to do. Number 10, the graph below shows the distance and time traveled by a remote-controlled car. So we have our distance and time. Which of the following is correct about the motion of the remote-controlled car? F, it's traveling at an increasing speed of 12 meters per second. G, it's traveling at an increasing speed of 6 meters per second. H, it's traveling at a constant speed of 12 meters per second. Or J, it's traveling at a constant speed of 6 meters per second. If you need to pause, do your calculation, do that now. Number 11. Sir Isaac Newton realized that the same force that acts on falling objects also keeps the planets in their orbits. He called this force A, electricity, B, friction, C, gravity, or D, magnetism. Number 12, the picture shows a car on a racetrack. It says this way is force from friction, this way is force from motor. If the car was in motion on the racetrack at a rate of 125 kilometers per hour, how would the car be affected if the force of friction and the force from the motor were equal? F, the car would maintain constant motion. G, the car would come to a complete stop. H, the car would increase in speed, or J, the car would decrease in speed? If you need to pause or rewind, do that now. If you're ready, we're going to flip to number 13. Number 13 says, the table below shows the data points of a lizard that started from rest and then started looking for food. So you have the time in seconds as 0, 1, 4, 5, 8, and 9. And the distance is in centimeters, 0, 4, 4, 6, 2, and 4. Using the table, which graph shows the motion of the lizard as it looks for food? So use the table to match it to the graph. If you need to pause to match up points and find the correct answer, do that now. If you're ready, please flip to number 14. The graph shows the distance an object traveled in 11 seconds. We have our distance and time. Which answer choice best describes the movement of the object between the times of 0 and 6 seconds on the graph? F, moving at a constant speed. G, accelerating. H, moving toward the north. Or J, stopped. And finally, number 15. The illustration below models our solar system. So we have the sun and then the planets. What's the main problem with the model? A, it does not include the orbit paths of bodies in the solar system. B, it does not reflect the true distances between bodies in the solar system. C, it does not show that the sun is larger than the planets. D, it does not show the size and location of each planet's moons. All right, if you need to rewind and go back to any questions at this time, please do. If you're done, if you'll go look at your answer, your Scantron, and make sure you've bubbled in every single answer and that it's neat. Erase any stray marks. And then when you're finished, you're going to turn both your answer sheet and your test booklet in with your name on it. All right, thanks.